So we're going to finish up the last part of this here, these slides. I've already gone and put them up as an assignment for this week for your reading assignment. This 11:30 efficient searching with MongoDB. So that's your reading assignment. I need to pull down another document or two and put that up there. I have not done that yet, so there should be another document or two up there today. As far as reading goes, but I haven't. I need to check because I haven't found a lot of resources that put everything that's in these slides in one place. So let's talk about streaming data. So what we talked about yesterday was mainly around how to start building up. We talked about indexes, and how that helps with any types of filtering or data search, data reading that you need to do. We talked about, which actually turns out speeds up your updates and deletes as well, because it makes it quicker to find the document to update or delete. So we talked about indexes. We talked a little bit about how to set up the text search. We talked about those aggregation pipelines. Those aggregation pipelines are a really important piece, as I hope you can see. They're a big part to the whole syntax about how you work with data. So what we want to talk about next is how do you stream the data to the client. Because what we've done so far, and you remember I mentioned that 2-array is not really efficient. Right? 2-array is the easy way out, because you can just say, okay, well, I'll do find, or I'll do my aggregate pipeline and then call 2-array on that. And that does end up giving me an array, but it's not efficient. Okay. So the important thing to do is to try and process the data piece by piece rather than processing it all at once. Okay, so that's where we need to talk about what cursors are, what streams are, as well as something called Oboe. This is not necessarily the only tool in the game, but it's an important tool in making this whole picture work. So, important thing to understand is if you're just running a find queries are pretty simple. There's only so much you can do there. You're basically writing a where clause. So those are pretty simplistic. But once you start building aggregation pipelines, things can become much more complicated. As you add things like lookups, as you add grouping, as you add all these additional stages, your pipeline can become much more complex, which means your query takes a lot longer to run. Okay? So sometimes you have to account for that and be able to, be ready for the fact that your query is not going to necessarily run instantly. So that's things to be careful with as you're working with aggregation pipelines. Aggregation pipelines is an important tool, but as you add more stages and more complexity, it will take longer. Notice that so, and especially if you have like a slow connection to the database or slow connections in general, then that will add to that because it takes longer for the data to transfer. So you want to be able to process the data, again, as it kind of comes in, rather than waiting for it all to come in, because it may take a very long time for it to finish the query completely. It will have the first few results a lot sooner than the end of the query. So maybe you write a complicated pipeline that's crunching a lot of data. It might take maybe a minute for that whole thing to finish, but you might have the first 10 results within maybe less than 100 milliseconds, right? So you don't want to wait until that 60 seconds when all the results are in to start showing results to the user. Does that make sense? And if you call toArray, that's what happens. If you call toArray, you're saying, I'm going to wait 60 seconds for all the results before I do anything. Can you see where that's a problem? So, if your user's going to your search interface and they type stuff in and they select some things and they hit search, if your screen sits there and it's blank for a whole minute, what do you think the user is going to think?
They might think it's broken.
Well, they're definitely going to think it's broken because no user thinks that anything takes a minute. I'll tell you that from experience. Nobody thinks that anything takes a minute. So if you don't tell them that something's happening, they're going to assume it's broken. So you need to be able to inform them that, hey, it's happening, and even better, give them some results as they come in. Give them results sooner than waiting for that. So what our goal is we want to be able to stream these results back to the client as we get them. So anytime we get a record from the database that comes out of this pipeline or out of a find, we want to send that back piece by piece by piece rather than waiting for the whole thing. So when you call find, both find and aggregate, both of those methods return a cursor. If you call find, you get a cursor. If you call aggregate, you get an aggregate cursor. Both are very similar, but with some slight differences. So both of those cursors implement a few different interfaces that you can use to iterate through them to get the results. One interface that you can use is you can say, I want to get all the documents at once, and that's calling toArray. Another way that you can do is you can say, oh, well, I just basically want the first document, and to do that, you can say, has next and then next. The combination of those two methods gives you the first record. There's also an event API, and there's a way to hook into convert it to the stream API. And then finally, there's a relatively new system that you can use, which is called an Async Iterator, and we'll talk about that one. It's really fresh off the press because it's something that's getting added to JavaScript, also known as ECMA scripts, in recent versions. And it's actually not formalized yet. It's on the docket for ECMA script 2021. But it's actually definitely, I would say, the best way to do this. So we will cover it for sure. But just recognize that this is really hot off the presses. It's not a standard yet. It's available in Node and you can use it today, but you're not going to be able to use it in the browser, okay? In browser-side JavaScript. So let's say we want to get all the results at once, and we'll go through these different methods. So let's say I want to get all the results at once. I can say collection.aggregate pipeline. Okay, well, that will give me back a cursor, and in this case, we said, that's an aggregate cursor, actually, but it still behaves like a cursor. So I get that cursor, and then from the cursor, that's where I have my options. The way I handle that cursor, I have a few different ways to deal with that. So if I say cursor.toArray, that gives me a promise for an array, which means I need to await for the array to actually get there. And then once I've got that, I can then take the results and spit them out in JSON. Now, you might say, okay, well, this toArray returns a promise, right? Which means it's going to take time, which means, is there any way that I can use toArray to get partial results? Well, promises don't provide a way to get partial results. It's either yes or no. It's all or nothing. So you either get either the promise is finished and resolved, or it's not finished. So you can't see the array in the midway. Does that make sense? If you're looking at a promise, you don't get progress events. Okay. The next thing I can do is if I want to say I want to just get the first result, I need to use two methods, hasNext and next. Next tells me whether or not there is a next result, and then next gives me that result. You might think that, using that interface, I could probably just directly call next and say, well, let's just see if next is null. As it works out, that doesn't actually pan out because of how Mongo's implemented things. If you call next directly, it will actually abort before the record comes in. So you actually have to say, has next and wait for a record to potentially come in or to determine that there is no record. So you wait that first. That says, is there a first record? Is there not first record? So if that comes back true, then you can go and get the next record and spit that back out to the client or use it however otherwise you need. And otherwise, if it's not a next, well, then you know that your pipeline produced no results. Okay? It's worth noting that all of these approaches here, you cannot mix and match. If you try to mix and match, you'll get into a lot of weird bugs because that's not supported by Mongo. Okay? So you can use the toArray, you can use hasNext, you can use some of the other methods we're going to talk about, but you cannot mix those methods together. It's one or the other. So do be careful as you're working with that, and that especially pans into talking about a pager. If you're implementing a pager, that pager needs to implement and use the same mechanism that you're using otherwise. It needs to fit with that. You can't use one method in your code that returns results and another for the pager. You'll get problems. So toArray has next. Next will give us that. We can use that to get the first result. Technically, I think you can do this in a loop, and you could use this to get all of the results with a while loop. But I would say that this is probably not the most convenient way to get all of the results with a while loop. One of the other methods is definitely better if you do want all the results. But this is the cleanest and most efficient way if you just want the first result. Like this is the best way to do that for sure. Okay. Next option. There's an event API that's built into the cursors, and this is based on the standard Mongo event, not Mongo, the standard Node event API. And with Node, anything that is an implementation of what we call the event emitter has a method called on. And on actually works very similar to, you've actually kind of, I think, used it in a few places, but it works the same way as you're familiar with like things working in jQuery on the front. You just say on this event name. So here I'm saying I want to do something when the cursor emits the data event. I want to do something when the cursor emits an end event. And I want to do something when the cursor emits an error event. So what I can do, and this, my whole goal here is to spit out the data from the cursor as JSON back to the client, but I want to spit it out piece by piece as it comes in. Okay, so the first thing I need to do, I grab the I'm going to actually say, here's the pipeline. We build up a pipeline, call aggregate, save that as a cursor, and then I need to start writing the document. So I need to start writing the response that's going to come out. So first I'm going to set the type of it to application JSON. So the browser or the client, whatever's reading it, whether it be the browser or whether it be a mobile app or whether it be Postman, that way we know, hey, we're getting JSON, we expect JSON data. I'm going to immediately start writing to the stream, and it's been a while since we did write, but write says put this in the output. Okay, so res is the response. We're going to start writing. Well, what are we writing? We're writing a square bracket and then /n for new line. So that square bracket is to say that we're going to start writing a JSON array. Cool? Because this whole thing that we return is going to be a JSON array. I'm just putting the slash in there and in for readability, so it's easier to read it when it gets to the client. You don't have to put a slash in. The new line character is not required, but it does help to be able to read the data when you get it back. Okay, so we're going to write that, and then we're going to start hooking up some event handlers. So the data event fires every time a new document is received. So every time there's a new document that comes out of this pipeline in this case, or if it were the cursor was from a find, that would be every document that comes out. We're going to call this callback. Okay, so this callback says take the document that you just read and let's write it out. So I'm going to say res.write, similar to what I did here. Res.write takes a string, so I have to take that data and turn it into a string. So I'm going to say this method that's built into JavaScript, JSON.stringify, which takes the document and turns it into a JSON string. So that'll take that, turn it into a string, and then I'm going to add in a comma and a new line, right? So the comma is to separate adjacent documents. Okay, so that makes sense. So I'm kind of building this, I'm writing this document out as I writing the results out as I receive them. Questions so far?
Does this work only with aggregate?
This works with find as well as aggregate. It's very quiet. I'm almost curious if my speakers are not working.
Can you hear us?
I just heard you, but I didn't hear Troy or Corey.
Oh, my mic was muted.
I think mine was too.
Okay. Okay, so that's resolved. So some people were muted. Any questions so far? Kind of see what I'm starting to do with writing the document out.
Yep.
So the data event is for every document you get. So we just say, well, we'll write a document out. And then finally, at some point, I'm going to reach the end of all the documents, end of all the results. And I need to then say, well, we need to terminate. We need to finish out that JSON. So for sure, I need to add in a square bracket, right? Because I started with a square bracket here. And there's no start event, so I can't hook that up with a start event. That's why it's just sitting out there. So I need to finally end it with that closing square bracket, okay? Now, why do I need the null here? What's that about? Any ideas?
Is that so the client knows you've reached the end of the stream?
Not really. Because the client knows that we've reached the end because we've called end. Here I'm saying res end instead of res write. So think about the JavaScript that's spit out. And I think I can try this with my example application that we were looking at yesterday. So I'm going to pull up the search, and rather than saying toArray, we're going to use this code here. So write the type, write, and instead of handling the end event, actually, I'm going to take off the logic for the end event a second. You can see what happens if I don't handle that event. And so I'm going to go API search. Okay. So this is what it looks like if I don't handle the end. See what's happening at the end? At the end of all the results?
You don't have a square bracket, but you don't necessarily need null, do you?
I don't have a square bracket. You're right, I don't necessarily need null. I do have to for sure have a square bracket. Did I not? Oh, there it is. So if I do have just the square bracket, not the null, look at what happens. So it terminates basically with comma and then bracket. Do you see that? Comma and then bracket. Is that valid JSON?
No.
It's not. Okay. So the last record cannot end with a comma. That's not valid JSON. Which one of the things you're seeing, you remember I have a plugin that normally would parse this JSON and show it to me in a friendly manner. Because it's not valid JSON, it's not able to parse it. So you would end up getting an error if you were trying to send this back to an AJAX call because it's not valid JSON. So by adding in that null as the last piece in there, and collapse all these, it does actually add a null record at the end, but it makes it valid JSON. Does that follow? The reason I need the null is because otherwise I'd have a trailing comma. Okay? Any questions on that? It's worth noting that there is an actual null now in that array, and I will have to deal with that in my front-end code. Okay?
Yeah.
But that's turns out is the easiest workaround for the fact that you have a closing comma. It is not the only workaround per se. To say that it's not the only way to work around that problem of adding a closing comma, but it turns out it's the easiest way. Okay. So what are some other ways that I could go about this and try to prevent that closing comma without adding a null? What could I do instead? Question for the class.
Maybe a ternary operator.
What do you mean a ternary operator?
Just to check to see if it's at the end or not.
By the way, Paul, your mic is muted, so you're not actually going through Discord. So nobody else on Discord can hear you. So if you would unmute your mic, that would help. Yeah. Because like I can hear your question, but nobody else can. Yeah. So, thoughts? Let's engineer this problem. Is there anything I can do instead? Instead of passing a null in there, what are some other options I could have taken?
Undefined.
Huh?
My brain is just trying to think of other things that mean null, and I was like, undefined.
I mean, if I was going to add something else, I could add an empty object, right? But then I have to determine that that's an empty object, and that actually leads to more code on the client side. So what I'm saying is there a way that I can not have an extra record, an extra thing at the end? Because what's the problem is I have an extra comma, right? How can I avoid that extra comma? Come on, there's got to be.
Could you have like an if statement at the end of the data that says if it's the last one,
Okay.
just not have the comma?
So somewhere in here, I could say if it's the last one, then don't write the comma. That's what your theory is?
I don't know. I'm just kind of thinking out loud. Yeah.
Well, is that possible? Is it possible for this method to know that they are the last one? Is it possible for that event to know whether or not they are the last record?
No.
It's not. It's not. There is no way to make that happen. Because you don't know how many records you're going to get out. Right? I could be the 99th record, but there's still 2,000 records to go. I don't know. Right? So there is no way to know that you are the last record.
Isn't
Huh?
is there a method? Is there a method in which you can drop the last item in an array?
So drop the last item in an array.
I don't know what that is. Like just like there is prepend and append, you can do the same thing here. After it's added, then take it off.
So could I do that? Well, effectively, then I would have. Could I do that? If I was going to do something like that, then I would have to. I would basically have to keep all the records in memory, right? Is what you're thinking, and then effectively I'm doing the same problem as toArray. If I keep all of these things in memory instead of writing them directly out, yes, I could do that. I could manipulate that array, but then I've lost all the benefit of doing this. Does that follow? Because then I'm not streaming the records. So I can't add them to an array because then I need a memory for that array, and that means I need to have space for all the records. But it also means that, that. So no, that's not really an option for me to use, put things into an array without eroding my benefits of doing this.
Could you change it so you're adding comma to the previous entry at the beginning of each write statement?
So you're saying move the comma to the beginning?
Yeah. That presents an issue for the first entry.
Yes, it does. It does present.
It
does present a problem for the first entry, but it solves it for the last entry, right?
Yeah.
That is a workable solution, and because yes, I can find out if it's the first record. That is possible. How do I find out if something's the first record? Let me save this. We can try this real quick just to verify that it's working. We can see the comma up here, but no extra comma down at the end. Right? So all I need to do is keep this out of the first record. How can I do that? Paul, you'd suggested something about a ternary. What was that about?
Well, it just seems simpler than FRS in this context. But I'm still thinking of something like a prepend or append, but something that deletes index 0.
Mm-hmm.
That's what. Delete index 0. Put that in.
So the problem is when I'm writing, right? When I'm writing to the response, I cannot undo that. I can't undo a write. Once you've written it out to response, it's not undoable. So I can't say, well, let's write a comma and then undo that comma that I just wrote. Once it's been written, it's been written. So I can't reverse or undo. Those tools don't exist. So how, if I'm going to put it at the front, how could I determine it if it's first? Somebody. How can I know if this is the first document?
I feel like me, along with everybody else who's not talking, I have zero idea.
My idea was how Paul was saying is finding the index of the document, seeing what it
Okay.
is, but I guess you can't do that.
How would you find an index?
Through the data in the document?
Well, you can't go off the data in the document.
The position where it's at.
Where are you having the position where it's at?
I don't know.
Okay. So the document in and itself cannot contain that data. That's not a workable solution. It's not an efficient solution. And I can't put that document into an array, because then we have the whole same problem as we had previously, where you have to have memory and you have to have the entire thing in memory. But what do I have? I know that this is being called repeatedly, right?
Yeah.
How do we normally deal with arrays? If we were going to say, I have an array and I want to write it out piece by piece.
You'd use a for loop typically.
You use a for loop, right? So I can actually kind of treat this as if this is a for loop, and maybe let's say let I equal 0. Right? So if I have a loop in a variable I loop through, right? I could say, well, let's start with I at 0, and every time we read a record, we'll plus I. Does that follow? So then I know if I is 0, it's the first record, right? So what you were saying about a ternary is possible if you do it as the first record. There's no way to know it's the last record, but it is possible to know that it's the first record. Any questions on that? So you say, if it's the first record, spit it out as blank. Otherwise, it's a comma.
Aren't you gonna write the for part?
The for part's having implicitly, because this is an event handler. Right? So I said cursor on data. I can't write the for part.
Okay.
The for part's happening because cursor on data is effectively a loop, right? That event gets triggered every time we get a new record. So it's kind of like a for each loop. Does that make sense?
Yeah, it's kind of like a loop in disguise.
Yes, it's already like a loop in disguise. So I could do this. The problem is there's still ways that this could potentially go wrong, and it means there's a lot of extra logic that has to run every iteration through the loop. You see that? It was a fairly simple method to write and run, but now there's an if statement in every loop. And that, as it turns out, having an if statement in every loop makes the whole loop slower. So typically speaking, for performance reasons, you typically don't want to you want to avoid having if statements in your loops. Okay, so if I go back to what I had originally, which was to say, well, we'll just ignore the fact, we'll just have that extra comma at the end and use a null. In that sense, well, then I've got no if statement. Does that follow?
Which one do we want? What you just erased or what we have now?
I would do it this way. It's fairly easy on the front end to ignore the null. It does take a little bit of extra code, but not much, versus the performance loss that you get by trying to avoid the extra comma is a lot higher. Does that make sense? Writing 4 extra characters is pretty cheap versus trying to write a bunch of code to just prevent 1 comma, 1 character is a lot more expensive. Got it?
Yeah.
So that's what you'll see with my examples. That's how I would stream it, is I just add a null at the end. That's how I deal with the extra comma. The next event that you'll see in here, so this triggers every time there's a new document. This triggers when we finally get to the end of the results. Error triggers if there's a problem. So I'm saying if there's an error event, then let's just go run our error handler. So I'm saying next error. That's what I'm doing there. Okay. So if anything goes wrong with the pipeline, probably because I have an error in my syntax or something with the pipeline, that's going to get triggered so I can see the error. Cool. So all of these 3 methods are effectively, they're sort of asynchronous, right? Because they're callbacks. So you can kind of see I've got synchronous code sort of up to here, and then from there on, this is asynchronous code. And things to remember there, because this is asynchronous code and because of how this works, these don't trigger your catch down here. Does everybody follow that? These events will not trigger your catch. So that's why I need to handle them. That's why I need to handle errors here, because I can't rely on the catch handling that, because it won't. Okay? So that's how you would stream it using the event API. As it turns out, there's a slight variant of that. There's something in Node called the Stream API, which is used for a number of things. Basically, if you want to convert a cursor to a stream, you just say cursor.transform stream, and now your cursor is a stream. But as it turns out, streams actually have the same 3 events: data, end, and error. So it's actually using the cursor's event API directly is actually equivalent to it being a stream. Cursors basically are streams. So anything you can read about how to use a stream actually does apply to using cursors directly and the event API directly. Cool? So I won't spend too much time on streams, because basically, this is the easier of, there's not really a reason to go over to streams, because you can use it directly using the events. The next option that we have is we can use the new Async Iterator. So the Async Iterator is a way for this cursor basically behaves, you can kind of loop over it as if it was an array almost, right? So remember we talked about the fact that you have a for each loop in JavaScript, and it's for of, right? Remember that?
Yeah.
So what makes this different is this word await here. For await. And this is there's some special methods that the cursor has to implement to support this. This doesn't necessarily work with a regular array or older things that don't support the that are not asynchronous iterators, because cursor has to implement the async iterator interface for this to work. But this is a new thing that's being introduced to ECMA script 2021. Okay, so if you're looking it up, this is a very, very new language feature. Okay, doesn't work in most browsers yet, but does work on Node. So what this allows me to do is just like all of the regular, async await syntax. The whole point of it is to make your code, which is actually asynchronous, look more like it's synchronous. We can do a conversion here. So what I can do, rather than handling the data events directly and the end event and things like this, I can kind of convert this to look like asynchronous code or synchronous code. So what I can do is I say for await, okay, and effectively what this does is it waits for each record to come in. So each iteration it's doing an await. It's not waiting for the entire result sets, it's waiting for an individual record. So we say for await const doc of cursor. So we're kind of looping through the cursor, waiting for each record. When we get a record, we say, well, let's write out document, and just like we did previously, also write out a comma and a new line. So I can loop through all the records that way. And then finally, when I get to the end of the loop, I know that I've reached the end of the results, and I can say res end null square brace. Everybody see that?
Yeah. Is this our preferred way to get this done? Is this our preferred way to
I'd
get
say
this
this
done?
is a cleaner way to write it than this. It gives you the same result. It gives you the same result, but I'd say this is cleaner. Now, this, because of how it works, this for await, if there is an error, it does go to your catch. These on error, etc. This does not go to your catch, but this does. So if this for loop, if there's any sort of error there, it does go down to your catch handler. So that's where, if you're going to use this does need to be in a try catch as usual. Cool. So this is the newest syntax, and I would recommend you use. I think this one is probably the cleaner of the two, but honestly, you can use either one. And there's some value to understanding both, because there may be situations where one works better for your particular application than other. Okay? Questions?
Nope.
I know this is a really weird loop, but I think that, stare at it for a little bit, you'll kind of understand, okay, it kind of makes sense. So those are your kind of two options for streaming the data. So what we're doing, if you've looked at all those examples, you'll notice that all of those examples involve streaming the data to the client in JSON. And if I go back here, let me go back to this Async Iterator version and say I stream that there. Say I refresh it. I don't necessarily see, I don't see a delay, right? Because this is a very simple query. It seems almost like it's coming through instantly. So sometimes one of the things you have to do as you're testing these pieces is to kind of play around with some of the numbers and play around with the way the network works. So for instance, let me say, first of all, I know that I'm doing paging, so I want to make sure I get all of the results. So I'm going to say page size is 2000. So that will mean that I'm getting back more results than I was previously. Okay? Everybody good with that? Now, even that still seems to be pretty darn instant, right? Now, if I go into the developer tools and go into the network tab, there's a drop down here to change the speed of your computer's connection. So what I can do is I can change it to fast 3G, slow 3G. It's normally online. Online is the regular speed, full speed. So I'm going to go to slow 3G, and that should make this a little bit slower. So this would be what the user experiences if they're on a 3G connection, right? So I refresh the page, and it took longer to get there, right? Which makes sense. you know. So if I look at what it took on 3G, how long did it take for me to see that data?
It took 0.76 milliseconds. Or no, 1.49
But I see
milliseconds.
2.2 seconds here.
Oh, okay, I'm looking at too many
Yeah, there's a
things.
lot of numbers there. So I think 2.2 seconds is the one that I'm interested in. If I go back to online and refresh, 12.5 for milliseconds, right? So it takes virtually no time to download this data if I'm on, a good fast connection. But if I'm on 3G, well, it takes longer, and that's kind of obvious, right? To some sense that it takes longer, right? But what I'd like to do is I'd like to give these two users, the one with the fast connection, one with the slow connection, roughly the same perceived speed. Does that make sense? I want it to make it look more similar, like their connection is faster than it is basically my goal. Okay? And I'm going to do that by loading in the results as I get them. Now, if you pay attention, right, when I refresh this page, when does the client show me results? Does it show me results as they come in?
No.
When does it finally show me the results? It doesn't show me the results until everything's loaded, right? So I have, on the server side, I'm writing them, I'm streaming them as I get them, but the client's still waiting for them all to be there. Okay. So, and if I take this to the more extreme example, let's say I go to stream, API stream, which is a service we'll talk about in a minute. If I wait for that to come up, it's going to take potentially some time. But you can see it start loading. But notice it hasn't, for instance, given my plugin to show it as JavaScript, show it as pretty JSON hasn't triggered yet. See that? So it takes some time, and then finally it shows it. Once it starts parsing it. Anyway. So one of things to think about. So we need to do some stuff on the back end to stream the data, but we also have to do some things on the front end in order to see that data streamed. So you might have noticed with the previous examples that we did, everything we sent back, we streamed it as JSON. Did you see that? So to stream it to the client, we need to stream it as JSON. We can't easily stream it to the client as HTML. And that's because Handlebars really depends on having all of the render data before you can render a view. Okay. You can't just say, well, I want to render part of the view. It's either all or nothing. So one thing that people have done, and the way to work around this is people have kind of split up their views into different parts. So they might do like, here's the header of the page, and we'll write that out as a view. And then we'll go, so we'll render the page header view. And then for each document, we'll render like the item view. And then at the end, we'll render the page footer view. So you could split it up into 3 separate views. Obviously, you can't use a layout then. But you could stream it as HTML that way. That becomes quite a bit of rejiggering to try and do that, and it doesn't give you a whole lot of performance, honestly, if you're still streaming the HTML. Okay? So to really get efficiency out of this, we need to stream the data as JSON. And that means we're going to render the data on the client side. Okay? Is everybody with me? So in order to stream the data, I need to be streaming it as JSON. I can't easily stream it as HTML. Okay? So how are we going to do this streaming? Okay? Typically, it's worth noting, Ajax typically waits for the entire response to come back to you. So the naive version of Ajax that we've used so far always waits for the entire thing to be there before we do anything with it. Which for small documents, for just saying, yes, your document was saved, not a big deal, right? I don't need to read half of done before I say you say your record was saved. But if I'm looking at, say, your search results and you're getting back 1,000 search results, I don't need to wait for all 1,000 search results to start showing you data. Does that make sense? So if you're using the jQuery Ajax method, it doesn't execute done or the success callbacks until you get the entire HTTP response back. And it doesn't really provide any options for intermediate results. If you want to come over here, Paul, that would be less feedback, actually.
Oh.
And you just look over my shoulder. Because then I was thinking this like, well, huh?
Can you hear that?
I couldn't hear that. I don't know. You're fine. Okay. I don't know if anybody on the call's hearing it or not. But that may be easier from your end. So the problem with using Ajax, the Ajax method itself, is that you can only do something when you get the full response, back. If you remember right, we kind of go back several weeks. The Ajax method in jQuery is built on top of the XHR API because it's kind of a layer to try and make it work the same regardless of what browser you're using, especially because older versions of IE had a different implementation of the XHR API in a lot of ways, so it helps to distinguish some of those differences. But there are some other options that are available out there now. So for instance, the Fetch API is kind of the newest way to do Ajax requests or asynchronous requests. And so they can be used, and the Fetch API is very similar to how Ajax works. But it doesn't require a third-party library. It's actually built into modern browsers. So the Fetch API you can use as long as you're not trying to support older versions of IE. I can't remember which version. I think the Fetch API is only in Edge. I don't think any version of IE supports the Fetch API. So as long as you're okay with not being able to handle older IE browsers, which at this point most developers are okay with, then you can use the Fetch API. The Fetch API in and of itself is still kind of, if you use the simple version of it, it still has that expectation that you're going to wait until the entire result sets come back. There's been some very recent work on the Fetch API because Fetch API is still pretty young. There's some experimental functionality out there now that you can use to process the response as a stream, meaning that you can process the data as it comes in rather than waiting for all of it to come in. But that's not supported on all browsers, and that can actually be a big deal right now. So that's there, and I think I have an example of how you can use the Fetch API to do this. But odds are it's not going to be supported on all browsers, so it's probably not the approach to use as of yet. but you can see what it is because I think, again, I'll go through an example of how to do that. Another way to do these AJAX requests, you can go directly to the XHR API and use it. Remember, the XHR API is what underlies that AJAX method in jQuery. It actually has some ways, if you delve into the API, people have figured out ways to actually read the response incrementally. So you can actually read the response as it's coming in rather than waiting to the end. There is some kind of hoops you have to jump through because it's not something for sure that's like built in and here's a clear way to do it with the API. So you have to kind of use some tricks if you're going to use the API to do that. But it can be done. Another option that's out there, and I think there are potentially some other ways to do this, but Oboe.js is another kind of library you can get, and it actually provides a wrapper around the XHR API, and that wrapper actually turns out is very similar to how jQuery works, so it's actually pretty easy to swap in. You can take the AJAX method that you have and replace Oboe, and all of a sudden now you can process results incrementally instead of waiting until they're entirely done. So that's Oboe is really the tool I would recommend you to use because it turns out to be the easiest one to use nowadays because it deals with a lot of those problems and makes it pretty easy to work with. But I want to kind of lay out some of the groundwork underneath so you kind of understand what's going on and maybe some of the tools that Oboe is using to implement that. Okay, just in case you need to go and use some other tool or need to work with the XHR API directly. Okay, questions?
Yeah, I have a question.
Yep.
Yeah, I have a question. So whenever you use Ajax or anything that like you put in the bottom of your script, like since it's like it's client side, don't you have to like apostate that, like put it like in a different file so people can't manipulate it?
Obfuscation on the front end really serves very little purpose.
Well, no. For JavaScript code, like where you to obfuscate JavaScript code, for example, if you're using like an AJAX request to a post, you know what I mean?
So just for the people who aren't informed, obfuscation is generally the process of taking code and running it through what we call an obfuscator, make it much harder to read. If you're seeing anything like a minified JavaScript, sometimes minification does a little bit of that, but it's not fully obfuscated. Obfuscated is more than that. So obfuscation is all about making the code so that you can't read it. That's honestly my feeling on that. Serves no security value whatsoever. Obfuscating your front-end JavaScript code, to me, serves no value because it's far too easy to undo that process. Okay? If you're giving the user the JavaScript, they have that code, and they can read it, and there's no way for you to stop them from reading that.
How come some of the sites, you know what I mean, do that? You know what I mean? Have you ever looked at that where they
I know that they do that. It largely comes out of if you're using something called Webpack and you're using React, you're probably going to see some code that looks obfuscated, but part of that has to do with basically, it's not that it's trying to obfuscate it, it's actually that it's trying to compact it and make it smaller files. Yeah, that's usually what's happening. And it's also ways, sometimes that happens too, to try and get around ad blockers. That's the other reason that sometimes that happens. Anyway, so that's not really relevant to what we're talking about here. Okay. Any questions about this stuff, this content here?
No.
All right, so let's talk about Oboe. And I'm actually going to pull up the official Oboe documentation here because they do a really good job of explaining why you want Oboe and why this is a great solution to it. And they even have some animations, which is things I couldn't easily get in the slides, so I want to show them here. So let's talk about what Oboe allows us to do. Oboe allows us to stream any JSON REST resource, any REST API that we have, as long as it's returning JSON data. It allows us to stream it in the browser. So this is how you implement the client side of it. Remember, you still have to have the server side of it that's actually streaming it in addition to this to really get the performance benefits. But this is how you do the client side. So we have a client-side web application as servers that provides it with data. The page isn't updated until the response completes. So if we can look at this example, this is our normal sort of setup. So the client initiates a GET request to get the entire page, right? To get all the data that it needs for the page. So we hit continue here. So it's going to send that GET request up to the server, and then you can see as it requests all that data comes back, but you just get a loading or progress bar. It's just waiting until it gets all the data. And then finally, when it gets all the data, it's showing it to the client. See that? So that's what normally happens with Ajax.
Mr. Chris, you just like left. You just like continue talking. Oh my god. You didn't realize you left?
I can't hear you.
You didn't realize you left?
Left.
Like you left for a good 8 seconds.
Well, what 8 seconds did you miss?
It's like as soon as you started talking about the loading, it started loading.
Okay. So maybe you go through this again, the animation, and we'll see if you can see it.
You reshare your screen because we can't see it.
It crashed. Okay. All right. Can you see this page? Okay.
Yeah.
So there's a few different animations on here that I want to show you. So this first one's kind of like what normally happens with Ajax. So normally with Ajax, you make a GET request from the browser, and you're going to say, okay, well let's go get some data. That goes to the server, and the server sends data back, and you can kind of see it usually comes all at once. But as that data comes in, you can see that it's gotten most of the data, but it's still sitting here with a blank white page, right? Nothing's happened in the browser yet because it hasn't received all the data. So usually it waits till the entire data comes back, and then it shows the entire page, right? So that's, doesn't create a good user experience, especially for people that are on a slow connection. With me? So that's what we're trying to improve upon, right? So we're trying to improve the perception of that. So if we're trying to use Oboe, see what happens? We start to get data back, and it immediately starts rendering the page. So it starts rendering data as we get it. So rather than rendering all the data at once, it says, okay, we got a piece of data, let's show it. We got a piece of data, let's show it. We got a piece of data, let's show it, right? So that gives even though the connection's the same speed, it still takes the same amount of time for the page to load. It gives a better perception for your users. Does that make sense? It doesn't speed up the data being loaded. In fact, it will slow it down a little bit, but usually not noticeably so.
The animation.
No animations.
You got kicked out again.
Really?
When you do the right when you do the animation,
oh boy,
kicks you out. You gotta reshare your screen.
Lovely. Okay, why? Okay, can you see my screen again?
Yeah.
So do you just at least see the animation? Or did it kick out before the animation played?
We saw the first
We
two.
just saw two so far. Okay, so you can kind of see that the idea is that gives the user a better perception of your website's performance. It doesn't mean the connection is any faster. The website's not technically faster if you're just looking at about how much time it took for the page to load, but it looks faster. Cool? It feels faster because it's being loaded in piece by piece. So, other places where this happens, let's say you're trying to do a search with map and you maybe are on a mobile connection that's a little bit flaky where it might cut out. So let's try this. So we go and we ask for some places on our map. And oftentimes, as they're saying here, usually the data arrives in bursts. So we say, okay, let's go get the data. So the web app has received most of the data, but it's not going to show any of it because it hasn't received all of the data. So you just got a progress bar until eventually all of the places show up, right? So, the user has to wait for all of these places to show up before it sees any of it. That's not a great user experience, especially on a slow connection. Okay. Similarly, well, what happens right? So what happens if we show the data as we get pieces of it? So we say, okay, well, we got 3 places. Let's go ahead and show them on the map. And then as more places come in, we'll just pop them in as we get them. So it still took the same amount of time to get and show all the data, but it's more useful to the user because they started seeing places show up before places show up earlier. And a lot of times, if you play your cards right, you can sort the data to say, well, let's show the closest places first. Well, because that's going to be usually the more relevant places. So you can kind of start by, if you sort the data on the server, sort it by the distance to you, the places that you get earlier are also going to probably be the places that are closer to you, you're more interested in. Cool? So that's part of the perception. The other thing that happens with mobile connections is mobile connections aren't always perfect. Sometimes you do lose connections. And the problem with that traditional AJAX approach is if you have to wait for all the data to get there before you do anything, if anything goes wrong, you're going to end up not seeing any data. So in this case, we're seeing, okay, we've got most of the data, but something went wrong. You're moving in a car and we lost connection to the tower, and now you're in a dead zone. You're just sitting there and nothing's shown because it didn't fully succeed. And in fact, at some point it times out, and so you just get a blank screen. It got more than half of the places, as you saw, but it ended up never showing you those places. See how that's a bad user experience? Because that's normally how your AJAX requests work, right? You get all or nothing. So then signal returns later, and it can potentially try to run the query again if you set it up that way. And then you download all the data. Bad user experience, right? Versus if we dealt with that more gracefully, and this is where Oboe can be helpful. We can say, well, okay, we'll show the ones as they come in, and we'll let the user see those, and now they go into a tunnel or whatever. Then we can wait till the connection comes back and just show the new ones. So we say, well, let's only request the data that we missed the first time. So we don't have to get all the data. We'll just get those and pop it in there. So overall, a significantly better user experience if we're able to stream that data to the client rather than waiting for all of it to pop up. So resource aggregation is another place where this fits in, where we're getting resources and data from multiple places. In your usual approach, it's like, okay, I'm going to go make a request. Data's coming in from those. And then we kind of wait for all the data to go in, boop, 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 until eventually we show all the data, but we only show all the data once we've got all of it. If we were instead to use a more streaming approach, you see we can start to show data as it comes in rather than waiting for all of it.
Is this how you basically do dynamic loading data? Where
this is part of it. This is one part of it. This is not the whole picture, but this is one tool in that picture. Right? So Ajax itself is part of that picture, but being more clever about how you deal with that data, how you load that data is another part of that picture.
Is it harder to do with Ajax? Is it harder to do with Ajax than
right? Yes. Yes. There's a lot of this is still actually Ajax. It's using the XHR API underneath. It's just reswizzling there's some tools in the XHR API that you can use to read the data before it's finished being received. Does that make sense?
Yeah, they just made it easier.
Yeah.
Yeah, they just made it easier.
So this is a really good, this point they make a really good explanation of where this kind of fits in. So you can kind of, as I say, step outside the trade-off between big and small JSON. So a lot of times there's this debate of how much data should I send back? And what happens if I send out too much data, or what happens if I send back not enough data? Because I could potentially chunk things up and make it smaller requests, which is the approach that a lot of people had taken, is let's say, well, rather than, okay, the problem is we have to wait until all the data is received, so let's just ask for a smaller chunk of data, right? But we'll ask for smaller chunks of data and ask for them multiple times, right? So if I make a bunch of Ajax requests, that's the other way that people have dealt with this. Not as cleanly, I would say, as this Oboe approach, but it is one that people have taken. So with the traditional REST approach, you can either request too much data, and at that point, then the application starts to feel unresponsive because each response takes too much time to load, takes a lot longer to load, or you can request less data, and while that first data, that group of data is being handled, you can make more requests, but that means that now I've taken something that used to be maybe one request, and now it's 10 or 100 requests, right? It's a bunch of trips over the network, and that has a downside, right? Including the fact that now you're making 100 requests over the network when it could have just been one, right? So that can slow down the network for all of your other users as well, right? So the advantage of this approach of streaming the data is that you don't have that trade-off of like, well, how much is too much data and how much data is not enough, right? How big do those chunks need to be? You don't have to decide. You just say, well, we'll send all the data, but we'll load it as we get it. So we don't have to, you don't have to optimize for, well, on these clients, these beefier clients with better connections, well, we'll ask for more data. And for our slower 3G devices, we'll ask for less data. Look at this. So this is the top one here is going to be, they're all kind of asking for data from the same server. The top one basically asks for all the data at once. The bottom one is going to ask for the data in smaller chunks, making multiple Ajax requests. And the one in the middle is going to make one Ajax request, but process the data as it comes in. And so you're going to see a difference in the user experience for each of those.
You disappeared again.
Why do these animations not like me?
I think it's your internet, Mr. Smith. Maybe you need new internet.
Oh, I know why. I'm on Wi-Fi. Back to this example. So I think I've misspoken previously. The middle one is the asking for, it says asking for a little data twice, and the bottom one is Oboe. So, see, this one waits until all the data is there. The middle one's making a second request to get all the data. So you do get kind of that appearance that data is being loaded earlier, but in the end, it ends up taking quite a bit longer because that second request, see that second GET request takes a lot of additional time. So this one that makes 2 requests is a lot slower than both of the ones that make 1 request. See that? So that middle one used to be historically how we would solve this. We would page the data, right, basically, and say, let's ask for less data multiple times, and then we'll show those as they come in, rather than trying to make 1 request and showing it intermediate parts as we go on. Okay. Was there anything in here else I needed to show? Downsides, yes. So downsides to, overall this is generally a benefit, and especially on slower connection, it's a much better improvement if you're working on 3G or slow 3G connections. However, because this is a pure JavaScript parser, and parsing JavaScript is a little bit CPU intensive, it does require more time to parse the JavaScript than just saying like JSON parse, which is what normally happens with your AJAX requests. So it will be a little bit slower to read the data, potentially to load the thing as a whole because of the parser, and it may require a little bit more CPU time. So that can be an issue if you're dealing with lower end device that are a little bit more CPU bound. So you do kind of have to test this and try it with your specific application to see, what are actually the perceived benefits. Does that make sense? But the big thing to pay attention to is what they call perceptual performance, in terms of how does it look to the user, even if it's not, at least by the numbers, faster, right? Okay. So for these examples going forward, and can everybody still see my screen? Okay. So I've written this example data source, and what it does is it just generates a million, or I think what I brought it down to was 100,000. And I don't think I updated this. 100,000. Brings back a whole bunch of documents is the point. And all of those documents contain is number 1, 2, 3, 4, 5, etc. So it's a whole bunch of data, but it's relatively small data. Okay. So I've got my this is in a route module, an API module. So the route to it is API/stream. First thing I want to do is I want to say that it's JSON data. So just like I did previously, I'm going to set the type to JSON, and then I'm going to write the beginning of the document, the square bracket /n. I'm going to end this with the null square bracket, so you can kind of see that structure. But I'm going to then loop in the middle and loop from 0 to just one less than 100,000. So that means I'll end up with 100,000 records. So this will go from 0 to 99,999. So each of those we say, well, let's write a single JSON document as a line with the line break at the end. And it just has one property called num, which is that counter. Okay? Everybody good? So if I were to look at that here, if you're looking at the example code, that's API stream module. That is set to 100,000 there. And if I try to look at that in the browser, there we go. So we can kind of see. Huh?
You're lagging.
Okay.
You were lagging.
Probably because it's processing right now. Right? So can you see the data as it's coming back now? Okay.
Yeah.
So there's the data basically that I'm producing, right? It's just dummy data, but it's enough data to see what happens, you know, and we can evaluate these different approaches. Okay? So it's an easy way for me to get 100,000 records rather than actually getting all of that. I'm going to kill the server because it's stuck. Okay. So this is the service that I'm going to use for these examples going forward. Okay? To demonstrate how these different approaches work and evaluate them. So the whole point is to just generate a lot of data. I'm not using a database in here because it would take a lot more setup. But it's, you know, enough to just have a bunch of data to see how this works out. So if I'm loading this data with jQuery, it might look something like this. I would say, well, let's go to the API stream. Let's say when it's done, we'll show all the items. And if there's any error, we'll show the error, right? So that's your basic structure of how we've done things so far, right? So I think if I look at my code, I've created an example with that. So what's the route to it, though? So it's jQuery, it's stream/jQuery, I believe. So on my website here, /stream/jQuery. Okay. So if I take that simple approach, you can see it's working. It's trying to load the data, but for the user's perspective, it's very slow, right? Because we can't do anything until done is called. Everybody with me?
Yep.
So when done is called, I finally show all of those numbers, but I can't do anything until that happens. So that's not a great user experience. Now let's look at the XHR API and see what maybe I can do. You can read a lot more about the XHR API if you want to dig into this and see how this works. The link's here. And there's some examples of where I pulled this kind of information. So first thing we have to do is we have to create an XHR object. So we're going to say new XML HEP request. And what I'm going to then do is I want to open that request. So open, it's a GET request, and the path that we're requesting is API stream. I'm going to say that I expect the response type to be the response as text. That does need to be as text, not as JSON, so we can kind of read it as it comes in. And then I'm going to start a counter. We're going to say scene is 0. So far I've seen 0 characters. Okay. So the way the XHR API works, it's all based on events. So I can hook up event handlers for when different things happen. So for instance, I can hook up an event for the ready state change, an onload event, and an on error event. So I'll come back to on ready state change, but onload is simply when the download is complete, here's the logic I want to run. Okay, so this gets fired when it's completely run the entire request and the response has been fully received. So this is what happens at the end. This is kind of our on-end event. And then we've got the error event, what happens if something goes wrong. So we can handle those different errors. What happens here with onReady state change, that gets called anytime that something happens. Anytime something happens with the request. So that includes things like what we call the ready state actually changing, which is, is the data ready? What point is it in the process of, like, have we issued the request? Have we started downloading data? Are we partially downloading the data? There's a few different states in there that you can look at. And I think if I go into the XHR API, we can see what some of those ready states are, because I remember there's a table. There we go. So 0 represents unsent, and that says that the client has been created, but you haven't called open yet. Well, we know we've called open because we did that already up here. State 1 is that has been opened, but we haven't received any data yet. So once we get to 2, then we have called send, and we know we've called both open and we've called send. Open is to start the connection, to start building it. Send is what actually starts it running. And then 2 says that, that we've received headers, we've started receiving data. And then 3 is data, 4 is done. So what we're going to say is, as this connection goes on, that's ready state keeps going up. So what I can do is at this point, we know that we potentially have some data. So I'm going to say if the state, greater than 2, so at 3 and 4, specifically 3, at that point, I know I've received some data, so I can ask what that data is. So the way we get to that data is we're going to say xhr.response text. So that's the text that we've received so far. I'm going to call substring on that because I just want the new data that I've seen, because as it turns out, this event fires every time we get new data, not just when the state changes. So I can say, okay, well, we've got new data. Let's take a substring starting at all of the bytes that we've seen. So I'm just getting the last ones. I can say, well, let's show the new data, and then we'll update the count. Right? So by using this, getting into this ready state event, ready state change event, I can actually look at the data, look at the text as it comes in, and start using that text. Now, it does become a little bit tricky because the text that we're getting in here, this is just a string. It's characters. I still have to would have to process this and turn it into, parse the JSON and turn it into objects, right? That part, as it turns out, is pretty hard, right? Does anybody see kind of what's happening here with the XHR API? Questions?
Nope.
I'm going to show an example of what this looks like. So if I use the XHR API directly, and this is not trying to actually show the data per se, what I can do is start making that request. You can see it actually turns out goes pretty quick. And I just display each chunk as I get it. So in here, it's actually coming back as pretty large chunks, because I can't see a chunk there. Let me try to run this again. Because of how things chunk out, sometimes they come as big chunks, sometimes they come out as small chunks. Really depends on what's going on with the machine at the time. So let's say, this is the first time, this is here, ends up being the first time the ready state changed. You can see the data that we've gotten back, right? So it's not the entire thing, but it's enough data, definitely enough data where I could start showing some of it, right? So each time I get that state change, I start showing the data. Now, you get weird things if you use this directly, because notice what's happening here. I have part of an object, right? So I have the start of, a comma, curly brace, quote. So I have kind of part of an object, but I don't have the entire object, the rest of the object's here. So this often happens as you're chunking the data, as you're streaming it. You often find that you get partial objects, so you have to kind of wait for. You can show all of these objects, but you kind of have to wait for the rest of the data to come in for that one to actually be able to show it. Questions? Okay. So
Nope.
you can use the XHR API directly to do some of this loading. Just the problem becomes there is more to it, enough that it's really worth having an API over it to make it easier to work with. But you can see that you can do it, and it ends up giving the user a better experience because we see the data as it comes in pieces, rather than potentially having to wait for all the data. So it's can be a better experience.
So it's basically loading it. So it's basically loading it asynchronously.
Well, all of these examples are loading asynchronously. This is asynchronous.
But it's like
it's streaming
like
it. That's the difference. All of these are asynchronous because
like
asynchronous just means that it doesn't happen immediately. Basically, they can do other work while that's happening. The difference is that we're streaming it, which means we show results as they come in, rather than waiting for all the results. Rather than dealing with it as an entire finished thing, we deal with it in pieces.
So that'd be pretty good for a user's page. So you can load, let's say you have 100,000 users.
Right.
You don't want to load them all at once. You want to stream them.
So we could do something like that. So that's using the XHR API, using the fetch API. Oh, wrong button. Using the fetch API. The fetch API has the structure that it's kind of like the way jQuery works, but different. So you say fetch and fetch the URL while I want. So I'm going to fetch API stream and then do something with the response. So then is where I handle the result of it. And then my catch is, well, something went wrong because this returns, basically fetch gives me a promise. So here I'm dealing with promises. Now internally to this, in how I write fetch, I can either, in this then, I can either take all the data at once, or I can work with the data piece by piece. Now, it's worth noting that there's a number of features in this example using the fetch API that are experimental. This is very much cutting edge stuff that's not been sorted out for the browsers completely. So while this may work today, this is not necessarily to guarantee to work in the future. But I want to show you what's available there right now, because this may eventually take over and be part of how we do it. But it's what they're working in and hashing out, but it's not a finished thing yet. Okay, so take this with a grain of salt. So this is doing the same thing as the XHR API, just using the fetch API instead. Okay, so with here, the first thing I'm going to do is I'm going to check if res.ok, that tells me whether or not we got an appropriate status. So if I got a 400 or 500 status of some sort, I would say, well, let's just stop and show the error. So if I get a good status, I'm on a status 200. I'm going to start proceeding and showing the data as I get it. So I need a few different things to make this happen. So here we say, take the response, go to the body, and ask for a reader. So a reader allows me to read it incrementally, read it basically as a string. So I say get body.getReader, that returns me a reader. I also need to construct a decoder because the way that this reader works, it returns it as a stream of bytes. not as a stream of characters. So I need to then turn these bytes into characters. So that's where a decoder comes in. So I'm creating a UTF-8 decoder so I can take the bytes that come in and turn them into characters, which then I can use. And then I need to use reader.read, and reader.read allows me to read things in chunks. Now the syntax here is kind of weird. This is pulled directly from their current examples, and I think this is the biggest part that may change in the future. But we'll kind of look at what we have here. So reader.read, and then I say then. Reader.read gives me a promise for some data, basically. And I say when that promise evaluates, when it resolves, I want to then do something with it. So I'm saying, here's my callback. It's a function called pump. And there is a reason that I need to have this as a named function, and we'll see that in a minute. So I'm creating a named function called pump, and that processes piece by piece. And then it's got some parameters in there, right? Now notice these curly braces. These curly braces are kind of weird here. It's probably not something you've seen very often. And honestly, I don't expect you to use it very often. Inside of there, those curly braces, normally we would see that as like done, comma, value, right? Do you see that? So those curly braces is a case of what we call destructuring. So this pump function actually receives an object which has a few properties. Namely, that object has a property called done and a property called value. So those do actually need to be called done and value. You can't call them anything else, or this doesn't work. Okay, so we're destructuring that object. We're taking off the done properties and the value properties and putting them into two variables called done and value. That's what's happening. Okay, so we're doing destructuring there. So done is a Boolean that says whether or not we're complete, whether or not the download has finished, and the value is a binary, basically a binary array. I believe it's actually a buffer that gives you the data that's been newly read, that's been read since the last time you told it to read. So if it's done, we can just, hey, the download's complete, and we can do our process that we need to do in terms of it being done. Otherwise, if it's not done, we can show the new data that's in the value. We may have to incorporate that with data from a previous read, especially if we haven't had a full JSON object. We may need to go back and kind of merge in the previous read with the current read. But we can show that data, and then we can continue reading. So when we continue reading, we're going to say reader.read.then again. And here I need to pass in ourselves. I need to pass in pump again. And this is why I needed this function to be named, is because we reference it again down here. Okay? So that's kind of what it looks like to do streaming data with the Fetch API. This is not something I expect you to remember, but I want you to see that, here there are some alternatives out there. There are some possibilities. There are things that are on the horizon. So, keep that in mind, that it is possible to do this. But it's not necessarily the easiest way to do this, at least today.
Is there any reason that they didn't use the arrow notation with the pump function? It says in the middle there, reader.read, then function pump. Why don't they use up there? Up higher. Yeah, right there. Yeah, is there a reason why that doesn't use arrow notation?
Because an arrow function I can't name in that context. I could. I would have to move it around a little bit. I would have to move it outside of. I would have to take this function and move it up before. It turns out that this is an easier syntax. It turns out that it's easier to write it this way. You could write it with an arrow function, but it's more convoluted. Okay, I'd argue it's pretty convoluted as is. This is the way, this is the API that they've, this is the current version of it that's been proposed. I honestly think that, once this gets completed, that hopefully that will change and it will be something simpler. But this is the API that's currently been proposed as a standard for JavaScript. But I really, really hope that they come up with something better. As you saw how on the back end, dealing with the data event is pretty easy. This is basically the data and the done event is pretty easy. This is basically the same thing, just more convoluted. So I hope they take a note from Node and try to implement these streams in a way that's closer to how Node implements them than what they are right now. But that's how they've implemented them on the client-side JavaScript world. Okay. So if we were to compare that, this is the way I did that with the XHR API. I did an example with the fetch you can read as well that basically does the same thing. And you can see it kind of reads that data in piece by piece. So both of those are, I would say about the same speed. I can't tell a drastic difference between using the fetch API versus using the XHR API. I would think that the fetch API eventually is going to be much faster than the XHR API, but I don't think they're there yet. But in the future, I fully expect that the fetch API is going to be the quicker of the two. Okay, so those APIs are there. You can get to them underlying. Ways to kind of deal with the data in pieces. But here's how we deal with it using Oboe, which I think makes that, dealing with that a lot easier. So Oboe works a lot like it's basically emulating the Ajax sort of method, but it also looks a lot like similar to how it looks a lot like Ajax. It looks a little bit like the fetch API. So basically, this is the way we write it. So we say Oboe, that's our Oboe object, kind of like $. So we say Oboe, and then pass in the thing that we want to get. So we're going to get API stream. That's the REST endpoint that we want to bring in piece by piece. And then basically, I hook up some handlers. So remember when we were doing this with jQuery, right? We had done and we had fail. So done was what happened when all the results were there. Fail is what happens when something goes wrong. Fail in this sense, there is a fail. It has a different sort of data that comes in. So done is what happens when the download is complete. And fail is what happens when there is an error. But what the fail handler gets here is actually different. It's a response. It's not the parameters that you get with the Ajax fail. So just be forewarned, you're going to have to put a little bit of different code into that fail handler than you did with Ajax. Okay? Yep.
And the question there, it's been in all these here, but we got API stream right after Oboe. Before it was just using ID, using jQuery, like a hashtag, form needs validation, something like that. I'm having trouble understanding what would be put in there for API
URL
stream.
that you're requesting. So if you're saying you're requesting users, it would be like API user.
Okay, before that was under the URL. Okay, before that was under the URL.
Yeah. What you're putting in is the URL that you're making a GET request to.
Okay, so it's in a different place.
There's part of it is there's two different ways to write that Ajax. You can either give it an object with the property name URL, or you can directly, if it's just a GET request, you can just give it the URL. There's two different ways to write it. Okay, but either way, Oboe expects specifically just a URL. Okay. So if you were doing this with, if you're doing that with a query, with a search, that might be, remember we were looking at the search API yesterday. So if I was doing API search, this might be query equals boots and min price is 10, right? So that might be my URL, right? Does that make sense? Your URL is just the resource, the endpoint that you're getting the data from. But it should always, I would expect it to be something under the API pathway, because it's going to be something that needs to come back as JSON data. It doesn't really, this isn't really going to work if you're getting back a HTML or whatever. This is not where you want to render a view, it's where you want to send JSON data back. So here, done and fail are kind of very similar. And if you just hook up, if you say Oboe, blah, 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 done and fail, you'll still actually get the same output as if you were doing Ajax effectively, because you'll still be waiting for all of the results to be done, to be received. In fact, normally the argument in here to done is all of the items. So it kind of has the same signature. Okay. Now I'm doing something a little bit weird. You'll notice that there's an underscore in here because I'm actually going to be ignoring all of the items to done, and that's a big performance benefit actually to do this way. The important thing that's new with Oboe is there's this method called node. So, and this you provide a callback that triggers as you get new data. And you can actually call node multiple times because node then takes a filter. So node takes a filter of what data that you want to receive. In this case, I'm just receiving an array of things, and this is usually how things will work out. So this is usually the filter that makes the most sense to use. There are a bunch of, you can read more about different pattern matching and different filters that you can use, but this is the one I'm going to use here. If we look a little bit, we say, I want to go to maybe the node event. Yeah, here's.
I saw real quick that the exclamation point doesn't mean not.
Yes,
it means
you're right.
root.
You're right. I'll go through each of these kind of piece by piece. So when you're specifying that first part, the pattern, that pattern says how do you want to read it. So the first part's the pattern and the callback. What things are parts of the response are you interested in? Let me go to examples here. So you've got a simple download. This is just to pull down everything. If we want to say, here's our document that we have, where we have an object with two arrays, we have food and we have bad things, right? So we have two arrays coming back. I can call node more than once to say read each of those records. So for instance, here I'm saying I want to read for each element in foods that we get, let's go do something. So here it's going to say, let's just log go eat some food thing dot name. So here it's going to read go eat some aubergine, go eat some apple, go eat some nuts. And then bad things, it would say, well, stay away from poison, stay away from broken glass. So those are different callbacks for different parts of the response. Okay. So that's if you have a more complicated response like this. Those don't happen all that often. I mean, usually what you're going to be using this with is strictly an array of things. So the pattern that I've specified here is the exclamation mark and then brackets around star. I believe this is actually the same as, it ends up working the same as exclamation mark dot star, but my perception is that this is a little bit faster. So here's the, at least my testing has shown me that, is this seems to be a little bit faster to do it this way. So the exclamation mark at the beginning says go to the root of the response, right? So the root of the response is that array. And then if you've got square brackets typically say this is like, hey, I want index 2, or I want property foo. So it's a way to index into the array. If you say star, which I'm doing here, bracket star, I'm saying I want any element in that array. Does that make sense? So this says any element in that array. So basically we're saying I want to get any, for every element in that root array, fire this event. Okay? Is everybody with me? So if your response is not coming back as a JSON array, if it's coming back as some sort of other object, you may need to change that pattern. But I would say that usually when you're using this, it's usually best to have it come back as an array of things anyway. So if it's coming back in as an array of things, we just say, well, for each thing that comes back, let's do something. So here I'm saying, okay, that's my pattern. And then my callback is this function here. So my callback says for each item, let's go say, well, if there's an item, then let's show that item. And the reason I need the if there is to handle that null case. Remember, there's a null at the end of this array because of how we spit it out. So I'm saying if there is an item, then let's show it. So if there is no item, then we don't show it. Okay. And then I'm saying Oboe, return Oboe drop. The reason I'm doing that, normally if I didn't put this here, all of these items would in the end be built into an array, and that array would be passed to done. Because I've already shown the item, and because I don't need to do anything further with it later and done, I'm going to go ahead and drop it, which says that it doesn't get added to this array. So that saves a lot in memory and runtime. So doing this Oboe drop actually makes this significantly faster. Okay? That's the reason I'm doing it, because this is a significant performance improvement. And that also means that what done get will be an empty array instead of being the array with everything in it. And because we don't have to build that array, this whole thing is a lot quicker. So if I go to stream /Oboe, you can see here's what happens as I'm trying to read that data. And you can see that's a really good user experience overall, right? So we start to see records almost immediately, even though you saw how long it took to get the 100,000 records, right? It still took a long time to get all that data, but we were able to see data very quickly. Cool. In fact, we saw so much data that it overran the first page. So, questions on this so far?
This is
Yeah,
really
I think
cool.
it's overall it's actually really easy to integrate, but it makes it so much better for your user. One of the improvements that you will want to do on this, especially if you're getting more data, if you're dealing with large amounts of data like I'm dealing with here, there is another performance improvement that you can do over this. This is fine for small amounts of data. This will still make it quicker if you have a query that is very slow, like it's very complicated because there's a lot of joins and a lot of grouping and a lot of things that need to happen. But if you have a lot of data and that's part of your problem, then you may need to do some chunking And the way that I do that, you can kind of integrate that into this pattern. And what I do basically, let's make an array called chunk. I'm going to declare a method called showChunk. So when we call showChunk, it's going to show everything. It's going to loop through all the things in the chunk, show each item, and then clear out the chunk. Okay, so that's what showChunk does. Show each item and then remove everything from the chunk. Okay, so what I'm going to use is this show. I'm going to start putting things into this chunk, and then eventually when it gets full, we'll show it. So inside of the node event, I'm going to say, okay, well, for each item we get, let's push it onto the chunk. Let's add it to the chunk. And then if the chunk reaches a size of 1,000, you can change that number to whatever fits your application. Here, for my large amount of data, 1,000 made a lot of sense. For you, it might be 10, it might be 100. It really depends on what you're dealing with. But once that chunk gets to a certain size, then I call showChunk. So effectively, this results in showing the data in chunks rather than showing each item one by one, and that leads to a whole lot of performance improvement when you're dealing with a lot of data. So that's not really, this I couldn't find in their documentation anywhere about how to do this chunking. At least one person had asked about it, but that's how I was able to implement it from my end. The one thing you do have to remember as you're doing this, you're going to have one chunk potentially at the end that's not complete, that isn't complete, so you need to call show chunk also in done. So that'll show the last chunk, as you may have one that never got shown. Any questions on that chunking?
This will be what we want to do then. This will be
Yes.
what we want to do then.
Lots of data, this is the way I would approach it. If you have 1,000 items or less, this is probably fine for you to just show each item one by one. But I would definitely say if you have more data, once you start getting to 1,000 records or more that you want to show at once, and maybe it's, maybe even just 100 records at once, then you might try chunking to help improve performance a bit. Because the idea is basically actually rendering the item and updating the view, updating the browser, actually updating the HTML actually results in a lot of time. So if you try to do that for every item that comes in, it can actually bog the browser down to the point where you don't really get the benefit from the streaming because all the records are pretty small. So yes, this is probably the approach that you're going to want to take. So that's it. We talked about how to, to kind of backtrack and refresh on what we've talked about between today and yesterday. We talked about indexes, we talked about text search, aggregation, we talked a little bit about how to analyze your queries, and today we talked about how to stream those results to the client. That's an important part, doing the server-side streaming as well as the client-side streaming with Oboe. Those are really important to get good performance in terms of the users, at least the perceived performance. Because otherwise it's like, well, the query took a really long time. It doesn't look so, it's basically a cheat by showing the records early to make it feel faster. Does that make sense? Also means you're using less memory on both the client and the server side. So any questions whatsoever about this streaming, whether server-side streaming, client-side streaming?
There's examples of all this in the code. There's examples of all this in the code.
Yeah, if
In
you
that
go look
repo,
at the
yeah.
repo, you can see all of those. Each of those different versions of streaming, all of these are using that backend, the API stream module. You can also see how this is done with the search. So like here I'm doing here I'm doing it with an iterator on the server side. If you go API search, all of the client side examples you can see if you just look at under views, stream, there's all of these examples for how to do this with front end stuff. So XHR and Fetch and Oboe and jQuery, those are all there. So you can read the individual implementations from the front end. Cool.